This is part 2 of the GEO503 June 9th lecture on YouTube. We just were talking about properties of your own objects that you set up. We can do the same with methods. Pictured here is how you would create a method on your own object in JavaScript. It's dynamic on the fly, just like we do with properties. I'm defining a new method called addLicense and setting it equal to a new anonymous function. By anonymous function, I mean it's a function without a name. Notice we're used to seeing function name and then parentheses. Here it just says function parentheses. Since this is just being assigned to the method, no name is necessary. Within the curly brackets is this function, and what that will indicate is whatever is within the curly brackets will run when the method addLicense is run. In this example, this method takes and increases the property on the object of number of licenses by 1. If we go to a couple slides back, I had set the number of license property. It's not showing up here. It was previously 10. After defining the addLicense function thusly, running the addLicense function here increased the number of licenses to 11 as the function specified. We're now going to talk a little bit about JavaScript object notation, or JSON. JSON is something we'll use a lot in ArcGIS API, and you'll see JSON a lot if you continue with JavaScript. Pictured here is not JSON. This is another alternative. The purpose of JSON is for you to easily pass data back and forth in a JavaScript object. This slide, however, shows an alternative for doing that called XML, which is also widely used. HTML is a form of XML. XML stands for Extensible Markup Language, and very like HTML, I'm sure you can see the similarities. You have attribute pairs where an attribute starts, you see the attribute name, for example, the value, and then /name to end that attribute. Attributes are also nested like they are in HTML. So here, picture we have an XML object county that has 4 properties associated with it: name, seat, largest city, and number of licenses. As I said, XML is widely used, but a problem is a large amount of space is taken up to define tags. I think I read somewhere that up to 80% of an XML file can just be the tag definitions and not the actual data. Here now is us getting into taking a look at JSON, or JavaScript object notation. JSON notation is very simple. The object is defined within curly brackets and is just a list of string pairs of attribute names and their values. An advantage of JSON is that it's human readable. It's very easy to look at a JSON object and see what's going on. So here is the same object as the XML object previously shown in JSON format. So you see the first attribute pair, name and Niagara. So the attribute is name, the value is Niagara. Double quotes for string values. Numeric values don't need the number of quotes, the quotes around the value, but they're still shown around the attribute name. Note number of licenses has quotes around it, but 10 does not. Also on this slide are a couple JavaScript functions to go into JSON and out of it, and we showed examples during class. Both objects are called from the JSON existing object, which you don't have to define. JSON and exists inherently. The method stringify on an existing object where you've defined properties converts that object into JSON. So here, this is the object we defined a couple slides ago. Notice the stringify method has converted it into a JSON text object. The opposite can happen with the method parse. In this example, notice we're starting out with a JSON object enclosed in curly brackets. I then issued the JSON.parse method on that, and the result is an object that we can get properties and methods from, like a traditional object. JSON can also be used to store arrays. An array is enclosed in square brackets and can include multiple objects. So in this JSON example, we have an attribute counties and it has multiple values. So counties is an array. The array is, we're missing a square bracket right here after the curly bracket after Medina. The square bracket indicates the objects in the array, and just like you would define an array in regular JavaScript, you see the different values here within the square brackets. So the array has 4 counties: Niagara, Erie, Genesee, and Orleans, each having an attribute for name and an attribute for street. We're going to switch gears a little bit and go over some examples of creating an HTML JavaScript example. And this section of the lecture may really help you in developing Lab 1. This is very similar to Lab 1 will be. In Lab 1, we will build a website to allow a user to calculate between different units. That's exactly what we'll do here too. For those that have taken GEO505, we did the same thing with a desktop Windows application as Lab 1 in that class. In this class, we're going to do this, build the same tool, but build it with a web page. And for example here, this is what our end result will look like. So to create a new HTML file, open up Visual Studio. From the File menu, click New and File. Choose HTML page, just like we've been doing during demos in class. And then name your HTML page and save it. In this example, I've named it calculator.htm. You can name it whatever you need to. As we see here, we talked about the header having metadata information about your web page and containing things like style sheets. We will enter the following into the header, and you'll do this in the lab, of course. The title of the web page will be Web Calculation Project. Pictured here are 2 different styles. We talked a couple classes ago about CSS, cascading style sheets, and the style tag is a way to develop style sheets right in your HTML page. Review, I believe that was June 2nd, review that class for more information. It might have actually been in June 4th. But as we learned in that class, here we're creating 2 different styles, my header and my radio text. And when we create our own style name that we can reference, we put a dot before the name. Both of these are used to create a style with the Calibri font, but the radio text font is only 12 point. The my header style will have a larger font size. We could save this into a separate .css file and reference it. We saw some examples on how to do that in class. I also showed some additional websites such as CNN, Wegmans, UB, and so on. For simplicity, we'll put everything in one file for this exercise and with the lab and for the lab. Now we will open a body tag /body. If you remember when we talked about the body tag, all of the visible content of your web page has to be within the body tag. So on just about any website, most of the content, most of the HTML, or nearly all of the HTML within body. So start with body here, and then we start with a table, which we also talked about how a table is a way to format and force content on your page into columns and rows. We're going to do that for our calculator. And I'm setting an inline style on the table to force it to be the entire width of the web page. Note the width 100% style there. I'm starting with a TR tag. Remember, TR stands for a row. And within that first row, we'll have one column. And a column is defined with TD. We're going to use that myHeader class we defined on the last slide. Notice the class equals myHeader. and then the text select which conversion run will be placed in this column. We end the row, start a new row with a new TR tag and a new column. Notice there's not much to this column. We're setting a style of a height of 20 pixels and then no text. We end with /td and then we end the row with /tr. The reason I put this in there was simply to give some white space between the conversion instructions and the rest of the table. To program the rest of the table, we start with TR, then my first column, TD, first and only column, and we'll use the myRadioText class. Refer to June 2nd. We also talked about input tags on that day. We spent quite a bit of time on that because there's a lot of different types of input tags. And within this column, TD, we will enter 3 input tags. Notice that here. And each input tag represents the 3 different conversion calculations your web page will do. Miles to kilometers, inches to centimeters, and Fahrenheit to Celsius. Looks like Celsius is misspelled. And these are radio buttons. The user will have a chance to pick one of these to choose which calculation they want to run. Notice all 3 are type equals radio. Notice that all 3 have the same name. As I mentioned earlier, that's how the HTML knows that these radio buttons work together. But each one has its own ID. Every tag on a page needs to have its own ID. This is how we reference it in code. So we end this row with /td and /tr. We're going to go to the next slide. Note we're not ending the table. We'll continue with this table on the next slide.